Alright, let's look at the homework 2.8, problem number 9. Right? So plane flies horizontally at the altitude of 5 kilometers, passes directly over a tracking telescope on the ground. When the angle of elevation is pi over 4, the angle is decreasing at the rate of pi over 6 radian per minute. How fast is the airplane traveling at that time? Right, so let's look at that. Right, so I already drew a picture. So this is the airplane flying this way, and we want to know how fast this guy is flying. When so angle of elevation would be here, so it's pi over 4, and actually we know that the rate of change of this angle is given to be pi over 6 radian per minute. So it's decreasing, so it's going to be negative, and pi over 6. Alright, so somehow we have to relate, the distance. Maybe I'm going to go straight down from the airplane. Right, then visualize this right triangle here. Maybe I should draw a solid. So here is our right triangle, right? Then changing quantity would be the distance, horizontal distance between the telescope and the airplane. So I'm gonna call it the x. It's since a horizontal distance. All right. Then altitude is fixed at the 5 kilometers. All right. Then we have information about the angle. So we have to somehow relate maybe altitude and the x and the angle. So this would be opposite, and this is adjacent. So the good way to relate opposite and adjacent and angle would be tangent. So looking at this right triangle, we know that the tangent, so we can set up equation tangent of theta is equal to, right? So it's opposite, which is 5, over adjacent, which is x, right? So so we have this, and if you want, we can actually write it this way. Since we're interested in the rate of change of x, we can just multiply by x and divide by tangent. So maybe I'm just going to do it, divide by tangent of theta. So you can see that this is x is equal to, and 5 over tangent of theta, right? But the reciprocal tangent is cotangent. Maybe you just go ahead and write it as a cotangent of theta, right? So let's take the derivative. So we're going to take the derivative with respect to time. Derivative x is dx over dt. Right, this is equal to 5. Right, derivative of cotangent is negative cosecant squared of theta, right? But we have to multiply by d theta over dt, right? So we have that. So so what we're looking for is the rate of change of this horizontal distance, which is what we're looking for. So this is actually dx over dt is what we are looking for. So we just have to compute this, right? So this is going to be, right, I don't like cosecant, so I'm going to go back to sine. So cosecant is the reciprocal of sine. So I'm just going to put the sine squared. And remember that the theta is pi over 4. Right, like that. So that's cosecant square. So just put sine square on the bottom. Multiply by d theta over dt, which is right here. So it's a negative pi over 6. Alright, so let's simplify. Right, so sine of pi over 4 is 1 over square root of 2 squared. So it's going to be, this is 1/2. Right, so this is 1/2. Right, so which means that you can get let's say 6 and the 1/2, so it's a 3 on the bottom. And let's see, so you have a negative cancel out. Oops. negative sign and the negative sign cancel out, and a pi times 5, so 5 pi. Right, so this is kilometers per minute. Alright, so let's type this guy in. Alright, so this guy, we found that, let's say 5 pi, so let's see 5, then I have to get the Greek letter pi, and 5 pi, and over 3 kilometers per minute. Let's submit for testing. Alright, it came back, and it looks like we got this one correctly. Alright, that's it. I hope that this was clear.